Hey yo, what's up, YouTube? It's your boy JOHABRAHAM. We're back, and we gotta submit this. Oh boy! So. What is going on? The student is trying to determine the acidity of succinic acid using conductometry. General flow of the experiment. Calibrate the conductometer with NaCl. I think that's the first part. NaCl is a strong electrolyte. Its conductivity is well known from literature. A solution of 0.4576. Okay. 0.7456 grams of NaCl in 100 milliliter of water gave a conductance of 12.04. Is that mentioned? Yes. This is used to determine the cell constant, which accounts for geometry of the electrodes in the device. Prepare succinic acid stock solution. The concentration of succinic acid is determined through titration. I don't know. I feel like I did this part somewhere on my assignment, somewhere on my notes. On me notes. I feel like I did this, but it looks like I did not. Saved photo, biochemical kinetics, that's for 10. No, come on, somewhere. That's 9. Simon 8, completed STUOP, introduction to general chemistry. That's assignment 8. No. That's 7, okay. We're going back. What? I did not even start? That's stupid. Okay, at least we're here. Prepare succinic acid stock solution. The concentration of succinic acid is determined through titration with NaOH. Titration is a procedure where a solution of known concentration is added to a solution of unknown concentration until the reaction reaches the equivalence point. All acid are neutralized. Dilution of succinic acid solution. This stock solution is diluted factors of 5, 25, 125 to measure how conductance changes with concentration. Okay. Conductance decreases as the solution is diluted, which is expected because there are fewer ions per unit volume. Preparation of sodium succinate solutions. So succinic, such a good name, succinic acid. Succinic acid is neutralized by NaOH, producing sodium succinated to salt. This solution is diluted by the factor. Now that's and its conductance measured. What are the terms in the question? Conductivity measures of how well a solution conducts electricity molecularly. Depends on the number of ions and their mobility. More ions, higher conductivity. Conductance, what the conductometer directly measures, depends on the cell geometry, solution, and the solution. Okay, units Siemens, of course. Succinic acid, Siemens. Of course, who would have thought? Not me. Oh, that's a lot of stuff opened. I'll do the presentation later. You might be wondering, why is it the same day 239? Because I feel guilty, okay? I feel like I did not use my last study session properly. That's why I did not add an extra day. Save. Let me take a piss. I think the headphone's pretty charged. Oh, come on. Okay. Okay, focus! Hey, sorry, set a timer for 30 minutes. Okay, okay, focus, focus. Hocus pocus, focus. Don't be stupid. Don't be stupid. It is easy to be stupid. Come on now. So, cell constant corrects for the shape and size of the electrodes per meter. Calculated as K cell using the standard solutions like NaCO. Titration method to determine concentration by reaction with the known solution. Here, succinic acid reacts with NaOH to find the moles of acid in the solution. Stock solution, original concentrated solution before dilution. Dilution factor, how much solution is diluted. Goal of the experiment, cell constant, molar conductivity. Okay. Okay. How do I calculate the first part? Come on. Cell constant, let me pull this up. There's there's I forgot the name, bro. Come on. Exercise 11. Handout exercise sheet 11. Handout, yes. So definitions have cell potential. Okay. Here's how you approach the calculating cell constant. What is cell constant? Cell constant accounts for the geometry of the electrode in your conductometer, where K cell equals K solution by G measured. K solution is the conductivity of the solution. From literature for standard solution here, zero point 0.1 mole. I don't know if it's 0.1. Conductivity of the solution. From literature for a standard solution. Okay, you know what? Let me search that up. Mm-hmm. Uh, okay, solution. Smarty verse E8F. Hey pal, you're giving me motivation to study. No fucking way. Hell yeah, brother. Oh, I appreciate that. I mean, I gotta submit this assignment today in about 2 or 3 hours, and your comment just gave me motivation to continue. Appreciate that, brother. Solution. So the cell constant has units of inverse meters. Shut the fuck. What is this? Conductivity of a solution. Okay, let me. For a standard solution. Well, Smarty Words E8F. I appreciate you checking out the stream, though. Appreciate that. 86 subs. Let's fucking go. Hell yeah. My pleasure. Hell yeah. Not gonna lie, trying to study every day. That did make a difference in me. I mean, this tracking stuff, tracking my studies on YouTube, that did change how I see studies. It made me feel like it's like going to gym. It feels good. The conductivity of standard solution is not a single fixed value for KCl. Why do we just get for KCl? What about NaOH? What stupid ass fucking AI. Electrical conductivity aqueous solution PDF. Ah, ah. Where's my boy? NaCl. Sodium chloride. Sodium chloride. 8.2 what? What? What the? Electrical conductivity indicated concentration mass percentage. I think that's not what I should be going for. I think I got my study, bud. Haha. You think you got your study? It's like you got your studies in control. I'm guessing that's what you mean. I mean, it made me curious. I don't know if you're okay with it, but what do you study, bro? You in school, college? What's up? Mm-hmm. NaCl. What? I don't get it. I don't get it. Is it true? Is this value true? Oh, you mean study buddy? Oh shit! Hell yeah! That's cool. Electrical conductivity of zero point 0.1 molar NaCl solution. I'm a medical student currently in first year. Let's fucking go, future doctors. Yeah. First year medical student. Shit. How do you feel? Is it a lot? Is it manageable? Is it too much? Right now I'm on my third semester, bachelor's in biochemistry, biological chemistry. And yeah, I wouldn't say I was following my curriculum exactly like how I should be following, because right now in my third semester I should be on Czech Republic according to my curriculum, but I did not pass all the subjects, so I had to take one more year to do my to do the rest of my first and second semester subjects I did not pass. It's like supply, you could say that. Redoing the subjects I did not pass. Uh, Electrical conductivity solution Siemens per meter. Okay, that number makes sense, but you know what? I'm not gonna waste too much time because I don't have too much time to look into this. Okay. Uh, so that's the standard value. K solution Siemens per meter. G measured conductance measured by your conductometer. I think that's this value, right? Yup, that's this value. Units checks per meter. So the cell constants have units of inverse meters, which makes sense because it corrects for distance and areas of electrodes. Okay. Use NaCl standard solution. From the experiment, measured G is okay. Literature conductivity. Plug into the formula. So the cell constant. What does this physically mean? G. How this is how well zero point 0.1 moles, not molal. NaCl solutions actually conduct electricity in your setup. K equals how well it should conduct in theory. Ha ha ha. The cell constant tells you my electrodes are spaced slash sized in a way that scales the measured conductance to actual conductivity. Once you have K cell, you can calculate conductivity of any other solution using its measured G. It's okay. By the way, for me in the starting, it is difficult for me to manage, and I'm not taking things that seriously, but with that I understand the importance of each subject's anatomy, physiology, and biochem with the time. That's highly relatable. Like my first year, like the first time I was in, first 6 months, 1 year, I was like, yeah, this shit's easy, boy. This ain't got nothing on me. But yeah, it it did had something on me, and I slowly realized that I need to take this shit serious, or else I'm gonna be left behind. So, and it's not that hard to take it serious. That's my personal experience. But yes, that is completely normal for not taking things serious. What does it physically mean? Solution actually conducts electricity. And one of the worst things that I feel bad is using AI. This stupid ass chatbot. I need to start referring books. Like what I actually wanna do is something like, yo, can you tell me which book and which page of that book should I refer to uh, to get the explanations and equations of this part. Yeah, life changes when reality hits hard, literally. Yes. You know, when reality hit harder for me, I failed an exam. It's a really simple exam, but it's an important exam. It's called Introduction to General Chemistry. I failed the exam 4 times. God damn it. And if I fail the fifth time that I just took this Friday, I don't think I'm gonna fail it. But if I fail it, that's gonna lead me to study ban. Fucking hell. But you know, stuff like those makes me feel okay. This is not like back in school. Vogel's text of quantitative. Here are textbook references: quantitative conductivity measurements and cell constants. This is a classic lab text for titration and conductometry, quantitative chemical analysis. You know, I actually, when I study, I want to actually refer books like these, but right now, ain't got no time. We're gonna go direct. The cell constant tells you electrodes. Okay, could you explain more on these two? Could you explain more on these two? Like, I understood that conductivity conductivity is what? Uh, Amount of ions moving, or could you explain again on what these terms represent? Also, the cell constant. Why is it inverse of meter? Yes, let's go carefully, step by step. G equals 12.04 into 10 raised to minus 3 per second. Second, G is measured conductance of your NaCl solution in your particular conductivity cell. Conductance is the ability of a solution to carry electric current. Depends on number of ions. Okay, G is the measured conductance. It's the ability of the solution to carry electric current. Depends on the number of ions, how mobile the ions are, the geometry of the cell, distance between electrodes, and okay. The geometry of the cell depends. Measured conductance is affected by the geometry of cell. Okay. Molecular view. Each Na and Cl minus moves in the solution under electric field. The faster and more numerous the ions, the higher the conductance. But G also depends on how far apart the electrodes are, their area. Because the same solution can conduct differently narrow versus wide cells, so it means your setup measured that ions in that's 0.1 molal NaCl allowed 0.1224 amperes per volt across the electrodes. Less that sentence is more intriguing. Kappa is the conductivity of the solution, an intrinsic property independent of the specific cell. It measures how well the solution itself conducts electricity per meter. This is the ideal value for 0.1 molal NaCl ignoring your specific cell. It tells you the solution's ability to carry current if electrons were perfectly 1 meter. Okay, that's what made 6. Okay. Electrons were perfectly 1 meter apart with 1 cubic meter, 1 square meter cross section. I'm guessing that's a cross section for the electrodes. Cell constant. Cell constant corrects your measured conductance to an intrinsic property of the solution. G depends on the geometry of the cell, but K doesn't. G depends on the geometry of the cell, but K doesn't. Y, its units per meter. The definition of conductivity where distance between electrodes, A, electrode area, G. What is G then? Rearranging. Length by area. Oh. Oh. So from this equation, does that mean, okay, wait. This is the problem. I get a lot of doubts. Okay. Right now I'm not getting what an ampere means. In my mind is not coming up with a physical property of that unit. So could you explain a bit more on this, as I'm a beginner to these terms. So cell constant can also be calculated using cell constant can be calculated using what? Come on, using the length and area of the electrode. One viewer equals Undertale. You mean Undertale game? Yes, I meant the game. But we could play the game, but right now I'm not in a position to play the game. Like, I have to submit the assignment. But yeah, that's what it means. It's like a fun. It's not a fun. It's like a break for me. When I'm studying for long hours, I could play the game Undertale for 15 minutes. It's like a break. Right now, I'm stuck on a spider boss, a female spider boss. That's where I'm at. Bombalinganyo. And I apologize the latency. It's like 20 seconds delay. It's just for YouTube. My Twitch stream, it's pretty okay, but YouTube is somehow has that latency. Okay, yeah. Ampere, physical meaning. An ampere is the unit of electric current, which is the flow of electric charge per second. Electric charge per second. 1 ampere equals 1 coulomb of charge passing through a point per second. Okay, okay. So it's the unit of electric current, flow of electric charge per second. Analogy, think of water flowing in a pipe. Voltage is pressure pushing the water. Current or ampere is the amount of water. Okay, okay. So the ions are like water molecules, and applied voltage pushes them. The measured current in amperes tells us how many ions are moving per second in response to the voltage. So 0.01204 ampere means a small number of ions per second are moving enough to produce this amount of coulomb per second of charge flow between the electrodes. Okay. Cell constant using geometry. Yes, the cell constant can be calculated using the physical dimension of the electrodes. So that means you don't need to know what this what is the conductor involved, or what is sodium chloride here. So either you measure G, use a known solution. Yeah, so sodium chloride is a conducting solution here. And so you measure G and use a known solution K to calculate. Measure electrode geometry in K cell. Okay, so that means you don't exactly need to know or the cell constant is not related to the conducting solution. Okay, now I'm gonna answer the question. So what is cell constant? Cell constant, okay. Feel it. Oh, I really want to show you what I'm writing, but no, that's not gonna be possible. So example 41. Example 41. A cell constant. Oh, it's given in the question. Stupid. cell constant K cell K solution by G measured. Oh fuck. Conductivity of the solution. Solution from literature for standard solution. Standard solution, that means 0.1 mole. What was it? What was it exactly? Come on. Intrinsic property. Tells us solution ability to move current. Okay. Kappa. Okay. Kappa equals 1.289 Siemens per meter. Come on, Siemens? You for real? This is the ideal value for, okay. It tells you the solution's ability. Solutions ability to carry current if the electrodes were perfectly 1 meter apart of 1 meter square cross section. And G, conductance measured by a conductometer. Conductance measured by conductometer. 30 minutes? No, please. No. Gotta be fast. He said we set a time for 30 minutes. Fast. Measured conductance measured by conductometer. Now, what was the literal meaning? Setup measured. Okay, wait. So ampere is coulomb per second. Okay. It's 12.04. 12.04 into 10 raised to minus 3. Minus 3 Siemens. So it means Are you sure it's 0.1? Are we sure? Rather 7456. You're right to question that. The point one NaCl is not what prepared in the lab. It's only literature reference used to calibration. Let's separate the two things. What is actually prepared? Molar mass, moles, volume, concentration. Okay, so that would be, so the lab solution was not 0.1. The measured conductance of solutions, this is what the instrument actually saw. Now the calibration is done correctly. What? This is why calibration is required. Yes, you're absolutely correct to question it here. No. No, I understood the literature value here, but the G measured is 12.04, and that value is for the 0.7 gram of liter solutions conductance, rather the one. So if I've given the values, it's 1.289 Siemens per meter divided by 12.04 into 10 raised to minus 3. It's not even working. Oh no. Mm, 0.289 divided by 12. So it's 107.056. 107.06 per meter. That's K-cell. What does that mean? Huh? What does that mean? My tells you my electrodes are space/size in a way that the scales the measured conductance to actual conductivity. No, I need more explanation on that. Uh, 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 uh. Come on, come on. I need to explain the G. So again, so for this statement, I should be saying this is for allowed so this would be the correct statement. Come on, fast. I got about 15 minutes, right? 20 minutes. Come on. Yes, that's the correct statement. Solution of 0.46 grams. Moves 0.012 of 4 amperes current per volt applied. So now the cell constant. Come on. Okay, I got this value. Could you explain more on what exactly this value means? Because I'm still a bit confused on the 1 by meter. I get it from an equation standpoint, but I don't get it on a literal scale. The electrodes are effectively separated by 107 meter per square meter of electrode area. That sounds weird because the electrodes are not meters apart, but it tells you how narrow and restrictive the current path is. No, I don't get it. My electrodes distort the conductivity by a factor of. So it's distorting the value of the standard literature value of 1 to 1.289. So is it dividing or because a bit wrapping exactly. I don't even know the spelling of exactly. Multiply, that's the part that actually clicks everything into place. The meter gives UG. The solution is a real physical property. Your cell constant is, so electrodes shrink the apparent conductor by a factor of 107. The real conductivity of NaCl, but your geometry forces the current through a narrow path, so meters only sees the conductance is as decreased by the factor of 107 due to the electrode dimensions we have compared to the literature So can I say the conductance is decreased by a factor of 107 due to the electrode dimensions we have compared to the literature. But I don't think it's just the electrode. But is it just the electrode dimensions, but also the amount of ions? Because it's not exactly 0.1 mole NaCO. No, those things are not mixed together. They play completely different roles. Okay. Your NaCl solution has some true conductivity. The literature gives the values being used as known for calibration is not coming from the electrode. The instrument compresses K into G using geometry. Okay, what? This is purely geometry. It says how long and narrow the current path is. Electron current must travel through a path that is effectively 100 times longer than 1 meter. Due to the electrode's dimensions. Okay. What kind of stupid ass? What do you want, bro? Fucking stupid. Just gonna wait. Oh no, I'm starting to get distracted. I'm nowhere even close. Okay. The molar conductivity at infinite dilution. Now, this part is pure theory. No experimental data are used yet. You're asked for first dissociation of succinic acid dissociated in two steps. What you need is step one, use Kohlrausch law. What? Molar conductivity at infinite dilution of the first dissociation deprotonation state of succinic acid gives them following literature value. Build a succinic expression, but you will get this value part C using. So part B is symbolic construction. You use a molar. What? Do it again. Do it again. Ow. We want the molar conductivity at infinite dilution of the first dissociation of succinic acid. Understand the concept. Molar conductivity, where K is conductivity, C is molar concentration. At infinite dilution, ions are far apart, so ion-ion interactions and reaches maximum value for weak acids like the first H2 succinic acid, I guess. We use literature ionic conductivities. No. The molar conductivity at infinite dilution. For the first dissociation of succinic acid, the molar conductivity at infinite dilution can be written as You know what? I'm curious on the structure of succinic acid. C4H6O4, okay. Okay, Smarty Wars, I don't know if you're still here. I'm gonna refresh the chat. So this part of the screen bit looks free. It's 30 minutes. God damn it. Then you know what time it is. I'm gonna switch to sequence analysis. We gotta make this. We gotta juggle this. Peace out, YouTube. I'm gonna start with sequence analysis.